All right, getting straight into iteration 2 and my implementation of seat levels using linked lists. You can see here I use typedef, which I thought was pretty nice way of customizing it. I did name it seats so that throughout the rest of these function prototypes, I didn't have to type structure, seat level. Instead, I just had to type seat. I do have to type seat, structure seat level here due to some rule where, since it's the data type is created here, you can't use it above, so I have to use structure. And this is actually that pointer to the next node, which creates a self-referential structure. It is just a single pointer, so it does just hold the address of that next node, and that does make this a linked list. Moving on to my implementation of linked lists, here we have a function called add node that uses both a double pointer so we can modify the address of head, which we check for null here, and then actually modify the address here, and down here we modify a later on address, and node to add, which is just that node we're trying to add to the linked list. And that is a great example of making sure that we don't have null pointers as well as using and dereferencing double pointers. Here's another great example of me implementing that linked list. We create that new linked list, we make sure it's not null, then while it's not null, we iterate through the linked list, displaying everything within it while we do. While I did have to consistently allocate memory throughout all of my program, this is the allocation of head, and this is the deallocation of head, which is the only node we deallocate due to some problems that I had, as well as it not being one of the requirements of iteration 2. Moving on to how I would implement iteration 3, immediately I would have to create a new structure right here beneath this seat level structure called team, and then probably do typedef with it. It would need to contain that linked list for the seat levels, as well as its name, the team's name, and the team's charity percentage. And then, of course, moving down through these functions, just kind of going to explain it as we go. Admin password check would need the teams, not the seats. Check pin wouldn't need to be changed. Setup sales would now need to ask the admin to enter a team and then ask him if he wanted to add another team and keep going until he said no. Run sales would now need to ask the user to enter to pick a team to buy seats from, which would then require a get team function, which I'd probably add right about here. And then get seat level wouldn't have to change. It might actually, no, it wouldn't have to change. Payment would need the team chosen. Print receipts would need the name of the team that they chose, so that we could do both of those properly. And then display totals would need the team linked list again, just so that we can, make sure that we're printing every single team's totals, sales at the end. Most of these functions wouldn't have to change, maybe here and there a little, but create node, add node, display seats, and search seats are the big major changes because they are currently set up to kind of specialize in adding nodes and creating nodes and all that for seats specifically. So we would have to modify them a slight amount to get them to handle both linked lists. As for the maintainability, you can kind of see here in iteration, the design notebook for iteration 1, that not only did I break up the tasks into, really small tasks, but I also had a lot of test data for it, which didn't actually end up helping me as much because my maintainability really took a nosedive here with iteration 1 with all of these crazy variables. It made it very hard to transfer functions to other things to test them, and it made it slightly hard to reuse them, but I actually did reuse a few of these functions in later homework assignments. Back over to iteration 2, you can see that I greatly improved my maintainability of my entire program. All of these functions have very minimum amount of are variables, are parameters, and they're actually, a few of them are actually pulled from other programs and implemented in here. So it's already very maintainable, very reusable, and very testable. Moving on to the reflection, I wanted to cover strings because they are one of the two topics that I think I improved the most on over the semester and through these iterations. You can see here that I'm using crazy functions with my strings. Later on throughout the program, I use even more crazy functions, again, with getting an int from the string, then validating that int. I use even more crazy functions with these strings. Here I am in printing the receipt to a file. I'm using sprintf and creating my own customized strings. Here in iteration 1, though, you can kind of see that I avoided using strings as much as possible and instead replaced them with, crazy things like char arrays or just trying to print it outside of the function as much as possible. One of my least favorite things is this constant char array. It really just shows how I didn't know how to handle strings then. And now in iteration 2, I really do know how. So I feel like I really improved over that. The second thing I improved on the most was definitely pointers. You can see here that I'm creating this constant or this variable, then creating a pointer and then using that pointer. And that's really not necessary as shown in iteration 2, where I'm really just, I really just feel like I've mastered pointers. So I was wrong. I actually do use that pointer again. But throughout all of this program, I'm much better at using pointers. Now, next for the thing I was most proud of was definitely my functions here. I just decreased the amount of parameters in them and their testability so much that I was just extremely proud of them during iteration 2.